Hi, I'm Dr. Marty with Central Wisconsin Ag Services, and today we're going to walk through the digestive tract of a cow. We painted Princess here to give you a good visual of what goes on. So initially, when a cow is eating, everything happens up here in her mouth like every other animal. The difference is that cows don't have any top incisors like most mammals. Instead, they just have a lower set of teeth and then molars in the back. The interesting thing is that calves, like babies, lose their teeth to get adult teeth at some point in their life. After the cow is done chewing her food, it goes down the esophagus, which I have outlined here in pink. And we will go all the way into the reticulum, which is the orange portion on the cow. Up here in the front, we have what her lungs would look like, and we call that the thoracic cavity. And everything behind the thoracic cavity is called the abdominal cavity, which is all of this here. So we have traced our food down the esophagus and we have now dumped into the reticulum. The reticulum is called the honeycomb, and that's very obvious when you look at the actual reticulum because it looks like little pieces of bee honeycomb. This area is really important because it's kind of the brain of the whole stomach. And the reason why is because the reticulum is controlling the contractions that happen in the rest of the rumen. The rumen and the reticulum are vital for a cow to live, because this is where all of the grass that she has eaten is broken down into energy. And the way that it's broken down into energy is by the microbes that are present inside of the rumen. The crazy thing is there are more microbes in one rumen than there are in the amount of people on the planet. There are about 20 million bacteria that are present in her rumen that are doing the job to break down the food. Along with microbes, we also have protozoa and also some fungi that are all going to help assist the cow breaking down energy. And when it's broken down into a substance called a VFA, which is a fatty acid, which is one of the major components to energy in a cow. So what happens as the food goes down the esophagus, it enters into the reticulum. The reticulum then contracts and pushes the food into the caudodorsal area of the rumen, which is right here. The food then moves down to our ventral sac, which is right here, for more mixing, and then moves into our cranial ventral area here. That is called a primary contraction. During the primary contraction, the reticular ruminal fold, which is located right here, will be lowered and it won't be as erect, which will allow some food to pass into the bottom part of the reticulum, which will move over to our next side, which we'll move over in a second.
But before we head over to the other side of the cow, we just wanted to explain what happens with the second ruminal contraction. So what you see here is you have the caudoventral aspect of the rumen, which contracts to push feed stuff up into the caudodorsal area of the rumen. From there, the caudodorsal part of the rumen contracts, which pushes the gas up into the esophagus, which then allows Princess here to eructate.
Okay, now we are on the right side of the cow. Again, we have all of our lungs and our thoracic cavity here, and then we have all of our abdominal area and structure behind the cow. I'll just point out some structures because there's a lot more going on this side than there was on the other side. We have our liver, we have our omasum, we have our abomasum, which would normally sit a little more on her ventral belly as opposed to where I drew it, because again, this is 2D, not 3D. We have our small intestines, which are outlined here in green. We have our cecum, or in the human terminology, our appendix. And then we have our large intestine here. So, we left off with moving food from the reticulum on the left side over to the right side, and the next place it passes to is the omasum, which is located kind of right in the middle of the abdomen of a cow. This structure, there's not a ton that it does besides absorb water. It's got a whole lot of folds inside of the omasum, which allows it to really have a lot of surface area, which is going to absorb a lot of the fluid that's come from the other side right here. After it's done with that, it moves to the abomasum, which is located here, and this is the equivalent of the human stomach. The pH that we have in our abomasum is going to be about 1.5 to about 3, so really acidic. Versus the rumen over there, that works great at about 6, so very neutral. That way all the bacteria and all the protozoa, all those things can live really, really well because they're in a neutral pH. As we move from our abomasum, where we have all of our chemical digestion, we pretty much have broken up most of the food particles at this point. So then we move into our small intestine, which consists of our duodenum, our jejunum, and our ileum. All three of these parts are really important, but are about the same in most mammals. We're not going to spend a ton of time on them because the majority of what we like to see is on the rumen. But what's going to happen in these areas is that you're going to have a lot of electrolyte absorption. So we're talking sodium, we're talking potassium, we're talking calcium, magnesium, all those great minerals that are going to be absorbed here in the small intestine. Our cecum is actually, we don't really know what is going on there to this day. We know that there is some fermentation, which is happening in the rumen, but the majority of the stuff that's happening in the cecum, it's just a little bit more breakdown by bacteria and a little bit more energy made there. But it's not super well known. And then as we head to the back end, this is our large colon here. This is where the final stages of water are absorbed. And so as we pass through the colon, we're going to poop out everything and try to absorb as much water as possible. And that is the ruminant digestion tract.